So good morning to everyone. Today we're gonna do Advent of Code 2025 day 3 with Rust. And yeah, I think I'm gonna start directly today. And yeah, let's do that. I have a little stream chat now, but I want it on top. I'll find a solution later. Okay. So, day 3. Our task is you descend a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They are all offline. Sorry about that. An elf apologizes as she tinkers with a nearby control panel. Some kind of electrical surge seems to have fried them. I'll try to get them online soon. You explain you need to get further underground. Well, you could at least take the escalator down to the printing department. Not that you'd get much further than that without the elevators working. That is, you could if the escalator weren't also offline. But don't worry, it's not fried. It just needs power. Maybe you can get it running while I keep working on the elevators. There are batteries nearby that can supply emergency power to the escalator for just such an occasion. The batteries are each labeled with their joltage, rating a value from 1 to 9. You make a note to their joltage ratings, your puzzle input, for example, this block here. The batteries are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries. With each bank, you need to turn on exactly 2 batteries. The joltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. For example, if you have a bank like 1, 2, 3, 4, 5, and you turn on batteries 2 and 4, that bank would produce 24 joules. You cannot rearrange batteries. You'll need to find the largest possible joltage each bank can produce in the above example. So we see here, this is our input. Then the largest joltage is 98 because we have the 9 here and then the 8. In this case, it's 89 because the 8 is the first and the 9 is the last digit, and we can only keep the order of the digits. And our end result is the output of all joltages from our banks. So what we essentially have to do is find the maximum from 0 to n-1, if n is the length of our input, and then have to find the second maximum, which could also be the same value as our first maximum, but cannot be the same number or at the same position, and search that until n. But we have to start at the first position, or at the first position after the first highest value. So let's take this example. I think here we can see it the best. Here we find the largest value until n-1, which would be the 9 here. And then we have to search for the second largest value in the input after our first largest value. And here it is the 2, so our maximum joltage is 92. And that is what this bank returns. And then we have to add all bank values up. So I think this should be a pretty straightforward puzzle. This is our input here in this case. So I think we should probably just go over to Visual Studio Code and see how we can implement it. So let's first start by creating the day 3 file And let's just copy over what we have here. And let's simply rename this to day 3. That's 4. It's day 3. The input file will, of course, be named O3. And yeah, let's do it later, but let's keep the header of the solve B. Remove the comments. And also let's keep the header of this solve A. We don't need this, and we can keep the tests, but yeah, we can keep the tests for now. So now this is all grayed out still because we haven't added day 3 to our module. So let's do that. And now day 3 is also properly highlighted. Okay, let's close the others. For those who are interested, this AOC day data is just some utility stuff I already wrote. You can find this on my GitHub or in the first recording. I explained a little bit what I did here and what we're using, but essentially this is simply a utility wrapper where we then call the solve function, where you get the day number, the file, and then read in the content. And if solve A is present, we use it to solve our kata and our task. And if solve B is present, we use it to solve the part B. So far, so obvious. So then let's copy our input and the test input over. I'm not gonna switch the input as I'm just copy pasting. So I've copied the input, day 3. Yeah, this is the input from the AOC day. And then let's copy over the test input. That's the little bank we already saw. Let's paste it here. That is not correct. Paste it like so. Check there are no white spaces. No white space at the end. Perfect. So this was the test input where we had 98 and 89. And now we should also copy over the test results. Give me 1 second. And I also have to let my cat out real quick. We'll be right back. And I'm back. So, yeah, this was the result of our test. Let's quickly switch over one more time to the test. So I copied the bank over and the test result here, which, yeah, our algorithm has to calculate. So, and then let's go back to Visual Studio Code. And let's get to our task. So we have to first read in the entire input. So we already have our input, and let's split on new line. I think there's a function for that. Split white space. I think white space includes new line. Let's check real quick. Okay, no, this is exactly only for white spaces. Then let's do split on new line. And let's map. Now we got the lines here. So we got a line, and now we have to map it. And now let's split on nothing, I think. I'm actually not sure how we can split on nothing. Let's check if we can simply say the empty string. We can simply use chars. That would be much better. Now we stream all the characters, so actually every number we got here. And then we have to map each char and have to parse it. So we cannot parse a character. That's of course unfortunate. I have to quickly Google that, how we can Rust convert char to, yeah, I32. Trick is 2-digit with radix, or our base must be 10. Yeah, okay, that makes sense. So we simply have to say 2 digits, and then we have to pass our base of the digits. So if we had binary digits, it would be 2. For our normal 10-base system, we can simply pass in 10, and then let's just say unwrap, because we are sure there's always going to be correct. And now we got our digits. So let's collect this into a vector. Or let's call it bank to stay with the main language. I guess the problem is that it doesn't know what is 2-digit. 2-digit returns an option of U33, 32. Yeah, that's all right. Makes sense. A value of vac U32 cannot be by map chars. Yeah, we need a flat map. No, we still need a map. This is a line, so we got a vector of U32, of course. And we'll probably have to collect this as well. Yeah. Now it makes sense. Okay, yeah, of course. With the lines, we collect a vector of U32 with this, which is one line, and then we collect that again, and that is results in a vector of vectors, which is, yeah, all the lines. So then let's iter over our line or our banks. Let's call this banks, and then we can say for bank in banks. So, and now we have to find the 2 largest digits. So let's make a helper function for that. Largest digit with ID X, because we also need the position. This is a reference vector of U32, and as a result, we want a tuple of usize, which would be the index, or let's start with the actual value and then let's have a usize. So now this is the value and the index into our vector. And then we can probably simply say max by. Yeah, iter max by. We first should enumerate. So enumerate results, converts a vector into a vector with the indices. So it's I and then val, okay, differently to what we have. We can change that, of course. And then we say max by. So we have our ID X and we have our val. And then we simply, return val. I think that should be all right. Let's quickly return 0, 0 here, so we don't get a compiler error because of that. So MaxPy is not happy with us. Ah, of course, we get 2 of those. IDX2 and val2, but I think we can just ignore the IDX values. And we simply need val1 and val2. And then we say val1 dot comp. Yeah, I think we have to look that up again as well. I think that won't work. We don't have to get the maximum. Let's quickly check again. What does MaxPy actually need? Examples x.compare y unwrap. Yeah, so this is probably a 3-way compare, so we need a positive value, a negative value, and a 0. I don't see... Ah, it's really just compare. So comp. And then we need to unwrap? This comp simply returns an ordering. Okay, perfect. And MaxPy apparently takes an ordering. Perfect. So now we have our maximum value, but we can unwrap that maximum value. So now we can simply return this. And then we can turn those around. That should work, I think. Ah, it's a reference to U32 that we got. Yeah, sure. Why not? Doesn't really matter. Yeah, that should be all right. I mean, we can dereference it later. That's no problem. So, yeah, this will give us the largest value. So let's use that largest div. Let's input and bank. And then we have our start IDX and our start value. And then we can say and bank dot skip until or start IDX many. Oh, does it? Yeah, start IDX many. So we have to skip start IDX many plus 1. And this won't work because we probably have to use a collect here because I said the return type is a vector. We can ignore the IDX because we don't need it here. And this is our end. So the collect isn't happy with us because elements of type and U32. Ah, okay. So should we? What are you? Intuiter? I think an intuiter should work here. Yeah, an intuiter. So the intuiter consumes the bank. Yeah, of course. That works, but it isn't what we want. No, it should work actually in this case. We only iter over those ones. I think it should make copy anyways, and the intuiter just clones the values and does not consume them. So I think it should work. Yeah, and then we have our values. We have our start and our end, which are both U32. And then the value for this should be our start times 10 plus our end. And then let's make this into a map statement, because then we can simply sum over it. It's not happy with us because we're not returning this, but we want to return this, of course. So, you're not happy because into iter. Or do we have? We probably have to say iter here, right? Iota. Iter. Yeah, now you're happy. Okay, but this isn't happy because the method called chain might not have had the expected associated types. Yeah, it's still a U32. Can we say no? That can't. What does VS Code? No. Can we say this twice? Yeah, but it doesn't change anything. But we probably can use a copy here. So we can skip the into iter, simply say map val, and then say val.clone. Yeah, and now we have the U32s. So, and then what is sum complaining about? Let's go back here. Let's use sum again so that it can actually import this, but it's still not happy. Vocabulary bound as the iter sum. Consider the generic argument. So we have to say that this sum should be U32. And now this isn't happy again. Okay, the borrower is later used here. Yeah, okay. So this is just it's bank rest. It's just getting out of scope, which is the problem here. So let's do it like this and then use the reference. Actually shouldn't be a problem. Ah, okay. I see the problem now. So the problem here is we use a reference onto the bank rest and then return a reference into the bank rest. And if we free the bank rest before this reference is actually freed, then we have a memory error because we free the value before we use the value after we freed the collection it is referencing into. So we could actually simply chain clone here and then return that type. Probably not. No, we would. Can we map on an option? No, but we can replace, or there's something like that. Nah, never mind. We can keep the reference. It doesn't really matter. We can have the bank rest here, out here. I think that's all right. Start and then we sum over it, and let's also make this the return value and say we want it. I actually think it would be better if we would make this an I64 and say here that we want this as I64. Because it could be that the sum with the large input becomes too big and we need an I64 anyway, so let's just do that to be on the safe side. Let's test it and we get an error. Let's see why. Oh, we called unwrap on a none. Where did we do that? Give me 1 second, I have to let my cat in again. Okay, I'm back. So, yeah, we called unwrap on a none. Let's check. It's happening on the max. Okay. I think. Oh, my cat is running on my keyboard. Okay, I think it is because here we have the bank, and of course the max value could be at the end. That was one of the problems, or one of the points I pointed out in the beginning. No, that's not what I want. Is there a but last? No. Too bad. So let's use a take, and let's say we want bank length. Nope, not leave. Bank len -1. And of course, now we have to collect that again. Let me think. See, we could take an iterator, right? Couldn't we take an iterator? A reference to an iter of a U32? Let's quickly check if we can do that. And then it's in type. And it says trait takes 0 generic arguments, but 1 generic argument was supplied. Trying to find here with the 0. Replace your generic bound with the associated item type. So item equals U32. This works, but now it doesn't want to iter because this is already an iterator. Nope. You need and mute. Okay. Yeah, okay. So the iter doesn't work, but the enumerate could work. But now it's perfect. But you don't work. Why don't you work? Because do we have to call iter on you again? Or into iter? Nah, this is where I still definitely struggle with Rust to know when I can make some, or what type I can use for the iterator, because in Rust, for example, I could simply use, not Rust, we are in Rust, in C# I could simply use an IEnumerable, and that would be equal to any collection that is iterable. And yeah, it could also be lazy collection, the IEnumerable, and here I'm just not sure how to actually do something like that. Maybe I can quickly find it by Googling it. Let's simply do that. First, forget about the iterator and other trait types. The core iteration trait in Rust is iterator. Its trimmed down definition as follows. Yeah, type and next. As you probably know, you can think of an iterator as a cursor inside of some structure with next. Method advances cursor forward, returning an element it pointed at previous natural. No. Iterator is a trait and it can be implemented by specific types. Yeah. .iter, yeah, that's what I thought. .iter.enumerate, okay. Course. Yeah, I think I have to look this up. I don't want to learn this while I'm on stream. This seems a bit much, a bit excessive. Let's go back to this code. And as this doesn't work, yeah, I mean, saying take and then saying, can't even say iter, I have to say into iter, and into iter. Yeah, but of course I cannot say collect because collect wouldn't be an iter. I could say collect into a vec of u32. This should be... Yeah, never mind. Let's go back to the vector we had before. I think that's fine. And then we simply have to say, instead of iter, we say into iter. And then we say collect. What's your problem here? Yeah, okay, again. Then let's not say into iter, but let's say map. And then val and val.clone. What's... Ah, yeah, of course. We have to still say iter at some point. Otherwise, this won't work. So, what's your problem now? Fighting with the compiler. Ah, of course, now this escapes the reference as well. Yeah, the clone call here was unnecessary, but we could say map this value. This is now our val inside the optional, and let's say val.0 and val.1.clone. And then this is not a reference to U32, but it's simply U32. And then it doesn't matter that this doesn't escape this. And it's also irrelevant that this would escape it. And simply do it like this. And yeah, that should be all right. And then let's run the test. And now the test is working. And then let's add our day 3 here, which is now simply the function we have here, where we define our little object, but instead of new, we should new is also right. It will just say that our result for task B is 0. And I added a little banner. I played around with ASCII art yesterday, and we now always get a little banner. There are a few different ones. We always get a little banner when we solve a task or when we execute this program. So now that we have our result here, let's go over to Brave again and to our advent of code and put that value in. And it doesn't work. That's not the right answer. Your answer is too low. If you're stuck, make sure you're using full input data. There are also some general tips about page. So let's check again. How can it be that this is too low? First, just to make this a little bit faster, let's comment out day 2 as we brute forced this yesterday, and that's why it takes so long. 197, yeah, I think that was what I submitted. Okay, let's check. So, yeah, we split our lines, we make 2-digit. Maybe let's look at the input and think about what case we did not consider. So, I mean, we know by using this that we're not using the same number. So in this case here, we're not using the we're not using the 9 and the 9 again, because then this would be incorrect, because then this would be 9 9, this would be 8 9. So there would be at least a value that is 1 too high. Here we would use 9 and 9. So that wouldn't work. We also checked with this that we don't take. And here we skip, so this isn't the problem either. So what we are looking at is the correct interval. What could be the problem? Yeah, it could be like they said, we're not processing everything, but that doesn't make sense as well. Maybe let's go over the test in detail and check if there's a problem there, because that's the only thing I can think of right now that could be going wrong. So we got a bank, so our input was 987, and the bank is 987654321111111. I think that is, yep, looks correct. So a parsing works correct. That could also be a problem, of course, but I don't think it should be. It shouldn't be. So then let's go into the loop. We get the largest value. Start IDX is 0 and start value is 9, which is of course correct. And then we go over this, and then we have our end value, and our end value is 8. And then we say start times 10, which makes it 90, plus the end is SI64. And now the result here is clear. I quickly have to let in my cat, sorry. And I'm back again. So this doesn't really make sense. I'm really just spitballing now. We could return calculate the value here and then return it just to make sure that the value is what we expect it to be. So now the compiler is inlining the val, I think. Yeah, it's inlining the val. Or we have to rerun it completely to rerun the debugger, the compilation process. You are 1 too low. Let's check if this... Nope. Doesn't want to. I think we cannot evaluate this as well. Start is not a valid command, apparently. Okay, but as the sum is correct, this should be correct. So we have 7, 8. That looks fine. Looks fine to me. Maybe let's use a little collect here. It's a result, and then we sum over the result. This just for debugging now. you should be a back of I64. And you want a call of into iter so that we can sum your values. So let's debug this again, and then we can look at the entire vector result, which is 98, 89, 78, 92. This looks completely fine. Okay, so yeah, that's exactly what we expected. Did I not copy the correct value? Let's go to Brave again. No, it's still wrong. Okay, so it was the correct value. Huh. That is quite unfortunate, especially because I have to quit soonish. Maybe let's just run the debugger on the main program and then we can manually check what is spit out. So here we have our result with 200 values. Let's quickly check this. Yeah, those are 200 lines. Seems correct enough. Nope, we need you. We actually don't need you. Let's do it like this. So 75. We have a 7 here. And yeah, probably afterwards the highest value is a 5, I mean. I really cannot think of a case where this doesn't work. So we need a 9, there's a 9. Why is the next highest value a 3? Why is for line 1 it's 93? That cannot be. 3 is not the highest value here. Not at all, it's simply the last value. Skip. Star IDX creates an iterator that skips the first n elements. Yeah, that is quite odd. Let me extract that again. Then stop this and rerun this. Now we're here and we have our rest and it's size 76 and yeah. Why is that even true? How many values did it skip? At which point was the 9? So we have a start IDX at 23 and a start at 7? For line 1 we said it was okay, right? For line 2 was the problem. Start IDX is 98. Oh. It takes the last 9, but even that doesn't make... No, it takes the last 9, not the first. Oh my god. Of course. That makes total sense. Okay, then we could also simply do a max and find that value. So for example, we say v.iter.find, and then we say where it's equal to that, and then we get that value. So yeah, I think that's the only solution I can come up with right now. So we don't have to clone here because we have to clone here later. Let's remove that. We want to unwrap here the IDX and the val. We actually don't need the IDX here. Then we can remove the max by. We can just simply say we want the max value from here. We unwrap the max value. Then we say find the value here. Nope. The x here where x is equal to val. And yeah, the problem is we have an and. Let's say into iter should be fine here. Now we have to use this anyway, so let's put it here, remove the into. Let's say enumerate because that's what we need. Then let's call this t because this is now a tuple. T.1 is equal to val dereferenced. And then we say unwrap. Yeah, dereferenced here. Exactly. It's dereferencing here is equal to cloning. So let's just dereference here. And this should be fine now. Because this searches for an element of an iterator that satisfies its predicate, takes the closure that returns true. Of the iterator, and if any of the return true, find returns some element. If they all return false, it returns none. In other words, it will stop processing as soon as the closure returns true. Yeah, so this will actually find the first value and not the last. So this is fine, and then we run this. And it's actually just a bit bigger, the number, but yeah, hard to find without correct debugging. Yes, and now this is correct. So, perfect. Let's quickly check. I have 10 minutes left. Let's check if this is doable here. The escalator doesn't move. The elf explains that it probably needs more joltage to overcome the static friction of the system and hits the big red joltage limit safety override button. You lose count of the number of times she needed to confirm yes I'm sure and decorate the lobby a bit while you wait. Now you need to make the largest joltage by turning on exactly 12 batteries within each bank. The joltage output for the bank is still the number formed by the digits of the batteries you've turned on. The only difference is that now there will be 12 digits in each bank's joltage output instead of 2. Consider again the example before. This becomes now much harder. No, we still need to find the maximum value. Okay, actually we can make that work with the function we already have. So the only problem is that we need here where we had the take bank.len -1, we now have to we have to I think slicing here would be better, and we need to do this 12 times. So let's quickly let's do it like this. We have a mutable result which starts at 0. Then we say for I in range, let's start with 1 to 12. I simply wrote range. I don't have to write range. So, and now we take this and we want to take it down. Let's take like this and let's make start IGX mutable so that we can say here we have to remove the let and simply have the let here. Oh, that's not possible in Rust apparently. Then let's say temp start IDX. So what we have to do now is, can we do a slice? Is that possible? Is there's the splice method? No, that's not what I want. Slice. As slice. As mutable slice. No, that's actually not what I want. I have to Google it real quick. Rust slice vector. Slicing vectors. Push 0. Let's search for slicing. Perfect. Yeah, exactly. Okay, read slice, use slice. Yeah, but how do I create a slice from? Ah, okay, we can actually. Okay, okay. For next time, I now know that we can use a slice instead of the vector type. I think slicing is something different than I expect. Yeah, that's what I want. Okay, that's perfect. Let's go back to here. So what we need to do then apparently is we have to say we want to start at the start IDX we have now and go to the length of our bank. We can cache this later. Minus, I think we should reverse this. That makes it easier. Minus our index. Yeah, okay. So now we skip the take. So now this should be a slice from our starting index. In the beginning it will be 0, and it leaves now 12 spaces left. Yeah, okay, no, then let's do 0 to 11. So in the beginning it leaves 11 spaces, and then it leaves 10, and so on and so forth. Then we say start IDX is equal to the temp start IDX we just had. And then this is important, we have to add to the result our value, our start, let's call it val, times, and this is now important, 10 multiplied with our index. What's the problem? I is a U size, and those are all U32s. Oh, we could of course just say U and I64. And you are an I64. And you are an I64. Now everybody's happy. And yeah, the result is now I64. course. You can, of course, type it like that. Then it's sure. And yeah, we simply now we have, for example, in the beginning we have a 9 and this is our very first number. Then that 9 would be, I'm not sure what the name of the 12 digit is, but it would be shifted to the left in the decimal value 11 times, which would make it our highest number, and then 10 times, and then 9, and then 8, and so on and so forth. And then we don't have to return val, but we can return result. And that was stupid because I was overriding solve A. And I actually wanted to override solve B. So then let's quickly comment out this one. And now I have to quickly copy over the comparison value. That is now way higher already for this small interval. Let's run the test and it fails perfectly. We only have 19,530. How is that even possible? Let's debug the test real quick. I think the logic is alright. It may be that the results we have here are way too small. Like, what the How is that possible? We are going from 0 to 11? That can only be possible if val is a U32. No, that doesn't make sense at all. Val is fine if it's a U32. We just need the largest number. Let's also extract that. Oh, I said function. I didn't mean function. So then let's debug this once and check if it works, what is going wrong, and if we can't find it directly, then I have to stop for today, sadly. So our call 9876. It only has 4 values. Why do you only have 4 values? Iter map val collect. Okay, yeah, no, that's fine. It could be that we only have 4 values that are possible in the beginning. Of course, because we're only leaving 4 values. We have to leave 3 values behind. Yeah, so we can only select from 4. And that is fine. The result should, of course, then be 9, because that is with the start index 0, which where's well, yeah, it's fine. Okay, so then we go to the next. And here we have a call size 98765. I think that is incorrect. I think we have to say start index +1. That was also something we noticed. Then this would have to be -1 in the beginning, and then we say here +1. Or we don't do it like this. We simply leave this at 0, and then here when we override it, we say +1. Stop again. Run the test again, see that it fails, check why it fails. It's val times, that makes total sense. Why isn't that working? What is the intermediate result here? 5390, that doesn't make any sense unless my logic is completely flawed and I just can see it. 1, 2, 3, 4. Now, why are your steps so small? Ten times I times the value. How can that be such a small result value? That doesn't make any sense. The first is 990? So our val is 9. And we say I times 10? How can that be true? I'm totally 11 times 10 is what? Total brain fart. We have to square it, not just multiply it. Yeah, that makes sense. Power. It's called power in English. Raise it by the power of I, of course. And I needs to be a U32. That is fine. And now we run this and this still fails. Fuck. Sorry. But it's actually quite close. Yeah. But I think I have to call it a day for now. I will fix this later, but yeah. This, yeah, takes too much time. I need to get ready for work. So, yeah, everybody watching this, sadly I cannot finish it right now. I may be doing it later. Yeah, I'll keep you updated. And I say bye for now. And yeah, I finished it the next day. It was actually just a small fix. Yeah, it was in the next stream, so yeah, the transition may be a little bit weird now. Don't be too confused. And I'm back. So, let's see what sense we can make of the code I already wrote. So, the input yesterday were these banks of batteries. And now we need to collect the 12 highest digits or the 12 highest consecutive 12 highest consecutive numbers here. So here we would have to collect 9, 8, 7, 6, 5, 4, 3, 2, 1, and then as many ones until we get to 12. And the problem here is that we need to get the highest number possible. And we cannot change the order. So in this case here, we would probably pick the 4 and then pick the 4 again and then take the remaining numbers. I'm not sure if that was actually the result, but that would be kinda what has to be done. Let's check. Yeah. Okay, 4 and then the 3 and then the 4 and then take the remaining numbers, or from here on take the remaining numbers to get the highest number possible. As we need, yes, we cannot change the order and we have to get the 12 numbers. So this is still a hard problem, of course, but the problem isn't as hard as it would be if we could, yeah, for example, I have no idea. No, but a hard problem where we could rearrange the order or in some form, or rearrange it n times or something, where we would have to enumerate multiple possibilities. In our case, we don't really have to enumerate different possibilities. We just have to search for the highest number we can find in a range, and that is the highest number possible. So I think the logical mistake must be in creating the slice here. So when we create the slice here, there must be the mistake, because I don't think the retrieval algorithm for finding the highest number, or the highest number with the index, is actually the problem. That would be weird. So let's, I'm pulling up. Well, let's try to make that possible. I'm putting that. Okay, that is scaling. No, wait. Let me duplicate this view. Split. Okay. And now let's make Visual Studio Code half of the screen and AOC the other half of the screen. So we can actually check this. Yes, and you go over here. Perfect. So now with that split view, I think we can actually make it a little bit more like this. I think this should be all right. I mean, we only have to look at the numbers. I will rearrange that quickly. So snap. Perfect. Okay. So now we are starting here. This can choose from, we have to leave 3 digits at the end, so it can choose from the first 4 digits. It can select one. And here in our debugger, this looks right. 9876. So then we go to the next one. And this can also choose from the next 4. So 8765 is also right. Yeah, and then, oh, 87654. Why do we have 5 possibilities now? That doesn't make sense. Temp start IDX. Let's rerun. Size 4, size 4, size 5. So it's size 4. Ooh. No restart. Size 4, and from now we have to look. Why is it bank length minus I and I is increasing? Let me think really quick. I think we have to take into account the start IDX, otherwise this won't work. So bank length minus I. I'm still confused why it doesn't work, because from my understanding, if I is increasing as fast as temp start IDX is increasing, which it does, right? The start IDX or the start ID is 1. Yeah, because we chose the 8. And the 8 is, of course, at position 1. We have to add the previous start IDX, I think. Otherwise, this will just increase further and further, right? Yeah, of course. Yeah, we because it's relative to the collection, the start IDX we have now. And the collection is relative to the start index we have. So if we don't increase it, so we have to say, yeah, we don't have to say it like this, we can simply say it like this. So, and now, yeah, start IDX is 0, so this is fine. Size 4, size 5, size 6. This didn't work, probably because it didn't recompile. Sometimes a little bit odd. Just restarts without recompiling. Yeah. Now we have a good restriction. Maybe that was even the only mistake here. It says it's alright. Both tests run. And we do this, and day 3 part B was this. And then, we have this here, we submit it. And perfect. That was the solution already. Very nice. Finish part day 3 part. Part 2, part 4 is interesting. Okay. In the rest of the stream, I was just babbling on about finishing day 1 soon enough. So yeah, stay posted for that. I will upload the stream if you're interested. And yeah, so that was day 3. I will upload the recording of day 4 soon. So stay posted for that. Thanks for watching. See you in the next one.